Hello and welcome to my channel. In this channel, we explore statistics in architectural research. I am Dr. Louis Diaz. In this video, we'll be diving into lesson 18. We will be covering the randomized complete block design. Randomized complete block design. The objective of this video is to help you to know when to use the randomized complete block design when you are designing the agricultural experiment. Let's get started. Randomized complete block design is one of the experimental design that we use in agricultural experiment, whereby in the experimental units a single factor has been observed to cause the variation. What are we saying here is that this is the experimental design whereby once you find out in your experimental units there are some variation, but only a single variation. For example, you find out in the plot where you want to plant your treatments, you find out there is a variation. There is maybe the soil fertility is not the same. The soil fertility is not the same. And the only factor that you observe which is not the same in these plots is one factor, which is the single factor. Now, the other thing that we want to explain under this randomized complete block design, what you have to do, you have to divide the fields into blocks. You have to divide the fields into blocks, which means we divide field into blocks. If we are doing the experiment in agriculture, maybe we have pens. So you have to divide those pens into blocks. So the way you are dividing those blocks, all the pens where there is a similarity, you put them on the other side, and the pens with another similarity, you put them on the other side. Remember, we are saying that it's only single factor that is the difference. Now, the other thing that we have to observe when we are dealing with this randomized complete block design is the issue of the treatments must be randomized in each block. So we are saying that the treatment must be randomized in each block. Remember, now you are going to have blocks, so make sure that in each block the treatments that you have must be randomized. And then the other thing that we have to take note when you are doing your experiment using the randomized complete block design is all the experimental units, they have equal chance of receiving the treatment. So we are saying that all the EUs, all the experimental units have equal chance of receiving the treatment. All the experimental units within the block, they have equal chance of receiving the treatment. We call that as a completely randomized block design, or the randomized complete block design. This is also one of the most important experimental design that we use in agricultural research, because if you are not using this experimental design, but you notice that there is a single factor that is not the same in your experimental units, you will end up not getting the correct results. So once you notice that there is this particular factor that is not the same in your experimental units, and you have to make sure that that particular factor will influence the results. But if it's not going to influence the results, there is no need for you to block. There is no need for you to divide your experimental units according to the similarity of those experimental units, unless you notice that the variation that you observe will cause the change in the observation. Because once you notice that change, you may think that the change is caused by your treatment, only find out the change is caused by that particular factor that is not the same in the experimental unit. We always make different examples. You are planting in your field, you find out the other plots, they are closer to the tap, which means they have the water closer. The other plots, they are far from the tap. You find out now that humidity will end up influencing that moisture will end up influencing the observations. So we'll talk about those examples as well. We do have some assumptions for this experimental design. The first assumption that we have here, the first assumption that we have here, we are saying that the homogeneity within the blocks, there must be homogeneity within block. So remember, you are separating your fields into groups. So in each group, make sure that there is a similarity. On that particular group, there is no differences. That is the assumption that we have. Then the other assumption that we have in this design is each block must have all the treatments. Each block must receive all the treatments. You separated your blocks, so make sure that in all those blocks you will have all the treatments, so that whatever, when you are observing, you won't say this treatment is performing better because it was only on that block where the soil fertility is in this much. So make sure that all the treatments, they will also appear in each block. Those are the two assumptions that we have. But we also have the limitations. We also have the limitations in this design. One of the limitations here is that it is always difficult to maintain the homogeneity within the block. It's difficult to maintain homogeneity. That similarity, homogeneity within a block. If we have more treatments, if you have a lot of treatments, it's always difficult to maintain the homogeneity in each block, because you have to make sure that in each block everything is the same. So it's always difficult to make sure that everything is the same within each block. That is one of our most important limitations when it comes to this one. Otherwise, once you notice that this experimental that we are designing, the randomized complete design doesn't qualify, you can go with another design. The randomized complete block design do have the general linear model. So the general linear model for this design is Yij is equal to mu plus the block effect plus the treatment effect, then plus the error. So here Yij is our response variable. For example, if we want to observe the effect of fertilizer in the growth of plants, so our response variable is that the growth performance of those plants. So we call it as a response variable for the jade treatment, for the jade treatment. Now we also have mu. We are saying that this is nothing but our overall mean. We also have our overall mean. Now in this case, as compared with the complete randomized design, in this one we also have the block effect. So that BI, the BI we are saying is the block effect or the group effect. Remember, we are grouping our experimental units. So this is a group effect for the ith groups or blocks, for the ith blocks. Then the other thing that we have here is the treatment. Of course, that's what we want to know, the effect of the treatment on our response variable. So this is the TJ. This is our treatment effect for the jade treatment. Then the last one here is the error, which is the EIJ, is nothing but the randomized error, a random error or residual error. Is a random error or the residual error. That's what we have in our general linear model. Remember, in our last, the previous video, we spoke of the complete randomized design, whereby we were saying Yij is equal to mu plus T I plus the error. But in this case, we added the block effect. But when you are analyzing your results, you know that you are not interested to know the effect of the block. But now that will help you to know whether this variation that you observe among your experimental units, is it influencing the observations the way you assumed at the beginning of your experiment. So this will help you to have that idea to see whether the variation that you observe, is it influencing or is not influencing at all, so that you can report about it as well in your results. So this is our general linear model for the randomized complete block design. To recap, we have covered randomized complete block design. This is experimental design whereby the single variation has been observed in the experimental units.
Do you have a topic you'd like me to cover, a question, and maybe you want clarity on a certain topic? Leave a comment below. Do not forget to subscribe, like, and share this video.
See you in the next one.